recorded videos. All right, guys, so after my big mess up there, we're going to go with looking at the green sheet, we see this equation, and then we look to the reference sheet and we found one that said sine, cosine plus cosine sine, and it was under the sum relations, and it said sine A plus B. Thank you. So we put in the 118 for A and the 62 for B, added those together and got the sine of 180. Normally that would probably be where I would have you stop on a test or quiz, okay? Because I might not even make it those easy of numbers. But this particular one says, now what does that mean it simplifies down to? What is the sine at 180? This is good practice. Okay, so over here, I would normally skip this one, but since we messed the last one up so bad, can you find one that says cosine, cosine plus sine, sine on your sheet? Where is it? It's under difference relations. And is it sine or cosine? So it's cosine of A minus B. And what are A and B this time? Why can't I move? Can I move you? Go away. A is 47 and B is 17. So this becomes what? Cosine of 30, which we could simplify down to square root of 3 over 2. Are you getting the hang of this? Okay. We're going to go and try one that looks like, I don't know, let's do 3. We don't need to do both of these, but can you find this one? That's ugly. What does it say it's equal to on your sheet? Let's see, this one has plus on top and minus on the bottom. So it's tan A plus B. So if we put in a 12 and a 168, we get tangent of 180, which is 0 over 1, or too fast? Too much? Okay. I'm going to skip down. Oh, this 6 is in radians. Let's just do one in radians. Can you do number 6? Cosine, cosine minus sine, sine. Where's that one? Cosine, cosine minus sine, sine. Okay, it's sum and it's cosine A plus B, right? So what is the cosine of, well, first of all, just simplify in here for me. Whoops. What happens when you add pi over 9 plus 8 pi over 9? Yeah, you get 9 pi over 9, which is pi. And the cosine at pi is not 1, it's -1. All right, getting the hang of it? Let's skip to, I don't know, let's do 10. Or did we just do one like this? Let's do 9. Sine, cosine plus cosine, sine. Can you find that one? Sine, cosine plus cosine, sine. Is that a sum or difference? Sum of A plus B. What are A and B, though? Oh, I'm writing sum again. Yeah. Did I write it right on the last one? Yeah. It is sine, right? Okay. Pi over 9 plus pi over 18. Did I substitute the values in right? Okay. Could use your calculator, right? 1/9 plus 1/18. Or this is 2/18, which would make it, which would reduce to pi over 6. Okay, you're not going to have to do so much of that on the quiz. You're just going to have to find them and substitute. What does that become? All right. Are there more? Oh, yeah. Okay. This is more like what's on the quiz. Okay. Look at 12 first, because 12, they didn't put parentheses in, and so these are really hard to read. but 12's not too bad. Sine, cosine minus cosine sine. Sine, cosine minus cosine sine is what? Sine of A minus B. And what are A and B? But they're 5 theta and 3 theta. So this would simplify down to 2 theta, and you can't do anything with it. This is more like what I'm going to ask you on the quiz. You won't have to even use your unit circle. Easy peasy, right? Now, what they were trying to do over here is there should be parentheses here, 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 and here. So can you try to find that? Tan something minus tan something over 1 plus tan tan. Okay, it's the difference, so it's tan of A minus B. Find it? And what is A and B? Negative 4 theta minus 3. Whoa, whoa. Man, my brain and fingers are not working together today. It would be the tangent of negative 7 theta. Now, just humor me. Do we have a tangent odd relations up above? What happens when you have a negative inside of tangent? Do you see it under odd relations? You could put it on the outside. I don't think so. No, I'm not going to be too worried about those, but I just want you to remember those are there, okay? All right, so do you feel like you know where those things are on your sheet? That was kind of what this front side was for. The back side is really good extra practice for the quiz, but some of it you don't know how to do yet, so I'm not going to talk about it today. All right, before we go back to this idea that we just talked about, sum and difference, we need to revisit yesterday because we did not get to the whole U substitution. So our brains are already warmed up, right? Because this is like the hardest thing we learned this chapter. I think so. I mean, the problems are going to get harder because we're going to combine some things, but this concept is tough for students. I think this is actually the bottom of 5A, is that right? Or is it on 5B? So this is the bottom of 5A. 4A, yep, thank you. Did I tell you to take out 4, or did I have the wrong thing here? Oh, is 5.4 on? Oh, I know what 5 is. Okay, so this should have been 4, just so it's right for the other class, okay? Stop. All I want to do is save this. Save. Okay. Yep. All right. So I started teaching the 7th hour yesterday, and I said I was getting a little loony. So I said, we're going to just ignore 2x for a minute, and we're going to call it giraffe. Okay. I don't know where I got that, but so I drew this little giraffe in here, and I was just pathetic, and they were giggling at me. Okay. Whoops. Negative square root of 3 over 2. So if I asked you to solve for giraffe, you would tell me the sign of something is negative square root of 3 over 2 where? This is an easy question. Look at your unit circle. Where is the sign negative square root of 3 over 2? 2 places. Negative square root of 3 over 2. Okay. So giraffe equals, that's the worst giraffe ever, 4 pi over 3 and 5 pi over 3. And then that is it says all, so we'd have plus or minus 2 pi n. Okay. My question is, this says all solutions, okay? So does this seem hard so far? Not so much, right? Okay. But what was our giraffe really? Okay. Really, this was a 2x. So are we done? Did we solve for x? No, we have to do what? Divide everything by 2. Now, that's a little hairy for some of you who don't like fractions. Dividing by 2 is taking half, right? So I'm going to take half on this side, and I'm going to take half here. Then there's a plus or minus, so I'm going to take half here. So I will get x equals, what does this become? What's half of 4/3? If you multiply, it's 4 over 6, which is 4 over 6 is 2/3. Does that make sense, guys? Half of 4/3 of a pizza would be 2/3 of a pizza. Okay. Plus or minus half of 2 pi n back here is 1 pi n. Now, the reason, think about this. I want you to think about this for a second. Go back up here. If I told you to graph sine of 2x, what would the period be? The period is normally 2 pi, but this is a b value, which would change the period to 2 pi over 2 or pi. Does it make sense why we ended up with a repeating every pi now? Because this has a period of pi. Because of that too. All right, we didn't finish though. What did we forget to do? Because I keep jumping around. Yeah, we got to do all of this by half too. So what's that one going to become? 5 pi over 6 plus or minus half of 2 pi n is pi n. Okay, this is the answer. Was that really that bad? Okay. Wasn't horrible, right? All we had to do was solve it and then at the end divide everything through. Okay, they're actually a little bit trickier when you do this. Because if you want exact solutions, you have to find all first and then figure out which ones of those fall in between 0 and 2 pi. Well, 0 isn't one of our solutions over here, okay? So we found all the solutions here, 2 pi over 3 plus or minus pi n, and 5 pi over 6 plus or minus pi n. We found them over on number 10. The issue is if we want the ones that fall between 0 and 2 pi, we have to figure out which of these fall between 0 and 2 pi. Well, guess what? 2 pi over 3 does, right? And 5 pi over 6 does. But there might be more. Because do you remember what the graph, what I just talked about? The sine has a period of pi. So if I keep going until 2 pi, how many times did it hit a negative whatever up there, square root of 3 over 2? 4 times. So to find the next one, what am I supposed to add? Pi. Okay, so if I add 3/3 here, what would I have?
5.
Okay, if I added another 3/3 though, I'd be up to 8 over 3. What's 8 over 3? Is it above 2? Yeah, so we can only go how far right here? Up to 2 pi, right? So we don't need anything above that. Now, 5/6 was 1. If we add a pi to 5/6, we'd be adding 6/6, so we'd get
11.
right? Because we had, you could do it in a calculator, 5/6 plus 1, math enter, you get 11/6. Okay? If we were to add another 6/6, we'd be at 17 over 6. Is that above 2? Okay. So these are the 4 places, and in our graph, it would have been here, 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 and here. Okay, do you see this last one was really close to 2 pi? Is 11 pi over 6 really close to 2 pi? All right, so this is a little crazy business. Now, to practice this idea, I used a program to make the back of this worksheet. Unfortunately, on the back of the worksheet, this program does some really crazy junk because it has you solve first. So I wouldn't necessarily ask it like this on a quiz, but you're going to have to divide by -8 first to solve this one. This is number 1 on 4B. Everybody with me? 4B, number 1. Okay, so all I'm going to do, I have to isolate the function first. So isolating cosine by dividing by -8. Now it will say the cosine of 2 theta equals, what happens with a 4 over -8? Yeah, it reduces. So we end up with a square root of 2 over 2, and it was negative. Somewhere along the line there, we had a negative. Okay, so rather than just giving you that, they made you do a step or two first to get to that. Okay, now, should we call this kitty cat, or should we call this giraffe, or can we just call it 2 theta? We can just call it 2 theta, but the idea is that we're going to have to deal with that 2 later. Okay, so 2 theta equals negative square root of 2 over 2. Where does that happen? On your unit circle, where do you get, for cosine, a negative square root of 2 over 2? 3 pi over 4 and 5 pi over 4. And normally that would repeat every 2 pi. Okay? But what are we going to have to do because of this 2 theta? We're going to take half of everything, right? Okay? So stay with me here. What's this one going to become? 3 over 8 plus or minus back here will be half of 2 pi n will be pi n. All right, and this one will be 5 over 8 plus or minus pi n. Now, if it said all, we would be done gloriously, okay? And on the quiz, it probably does say all solutions, and you get to stop here. But this particular one says we want to figure them out between 0 and 2 pi. So we can't leave it in terms of n. We have to find the exact number of solutions. So one of them is 3 pi over 8, and one of them is 5 pi over 8. But apparently we should add pi, which should be straight across the unit circle, but we don't, these aren't on the unit circle anyway anymore. So what is, how can I add 1 to 3/8? Okay. Okay, so 3 and 8 is 11/8. We got to make sure that's not too far. Is 11 divided by 8 over 2? No. Okay. If we add if we added another 8, though, we'd be at like 19 pi over 8. Is that above 2? Okay. 5 pi over 8 plus 8 pi over 8 would be, okay, I'm going to put it out here because I don't have room. They're not in any particular order, sorry. Now 13 divided by 8 is like 1 and 5/8, so I'm still not over 2, right? Okay. If I added another, I would be. So there's our 4 solutions. I'll get there, yep. Because we're going to have to divide by something else eventually here. This is a tangent question, and it's written kind of ugly. What would you do to isolate the tangent? Subtract 1. Now, it's looking really gross here. It says 3 plus square root of 3 all over 3. Can I rewrite that 1, guys, as 3/3? So now what happens? Yes, the top just becomes root 3. And what do you do when you add and subtract fractions? Yes, so it's root 3 over 3. Again, I will not make you do that on a test or quiz. I would give you this question right here, okay, with it all isolated. Now, okay, it's a tangent, and we could call this giraffe again, or we could just call it 2 theta. Where is the tangent square root of 3 over 3? Now, I know some of you are still struggling with tangent. What ordered pair would give me square root of 3 over 3?
5 over 6.
No, I want to know what the ordered pair would look like so that everybody can be looking for it.
3 over 3.
I don't think it's negative. Okay. But isn't, guys, this is the ordered pair we're looking for, yes? Because when you put the 1 over the square root of 3 for y over x for tangent, or sine over cosine, then that would rationalize to this. That's what people struggle with, right? Because tangent isn't on my stinking unit circle. All right, so I'm looking for that ordered pair, and that happens at pi over 6. Where else would I get it to be a positive square root of 3 over 3, though? Yeah, if they're both negative, which is where?
4, 5. Oh, never mind.
Okay, how far apart were those when you're looking at your unit circle? They're straight across from each other, right? Why are they straight across from each other? Because they're pi away from each other. And why are they pi away from each other? Because it's tangent, and tangent has a period of pi. So we could put plus or minus pi n here, or we could even put plus or minus 2 pi n. It wouldn't matter. Would you have put 2 pi? Okay, so let's put 2 pi. Now what do we have to do to find theta? Because we put both of these answers here. If we had put only one of them with a plus or minus pi n, that would have been fine. But since we put both of them, it doesn't matter. So I'm just trying to go with what you guys would probably do. Now we're going to take half of everything. Okay, half of 2 theta is theta. Half of pi over 6 is pi over 12. Half of 2 pi n is pi n. Half of 7 pi over 6 is 7 pi over 12. And half of 2 pi n is pi n. Okay. Again, if it said all solutions, we'd be done. But we got to do 0 to 2 pi. So the first one is pi over 12. There's another one at 7 pi over 12. If we add pi, we're adding 12 twelfths. What would that become? That's less than 2. Can we add another? If we add 12 more, we get 25 twelfths. 12 times 2 is 24, so we'd be over 2. 7 pi over 12 plus 12 twelfths is what?
Wait,
19, right? Is that less than 2? Okay. So between 0 and 2 pi, there is 4 solutions for that one. Now, one more, I think. Okay, do you notice the difference? What's happened to our giraffe? It's a 3 theta. It's also on the other side, but it's a 3 theta. All right, again, this is just a gross question. Negative 2 plus square root of 3 over 2. What do I have to do to both sides to isolate sine 3 theta? I got to add this 1. And I'm adding a 1, so I need a common denominator of 2 over 2. So what would it all simplify down to? If I make this one big fraction, I just have square root of 3 over 2 because the negative, that's not going to be on the quiz. Okay, again, I would start you out right here. Okay, so our 3 theta is equal to, where is the sign square root of 3 over 2? Okay, I gotta look. Sine square root of 3 over 2. Yes, you are correct at pi over 3 and 2 pi over 3. It's also positive square root of 3 over 2. Everybody good? Okay, what do I put on the back? Okay, plus or minus 2 pi n. Now what do I have to do? I have to take, yeah, let's multiply by 1/3. That'll go so much smoother. 1/3, 1/3, 1/3, 1/3, and 1/3. Okay, so 1/3 of 3 pi is just pi. I'm sorry. It's theta. So I said I'm sorry. Okay. 1/3 of 3 theta is just theta. That's better. 1/3 of pi over 3 would be pi over 9. Plus or minus, this would become a 2/3. Ooh, yuck. And down here, 1/3 of 2 pi would be 2/9. I'm sorry, 2/3. 1/3 of 2/3 is 2/9. 1/3 of 2 pi would be 2 pi over 3. And that should be an n back there. Okay. Guess what we get to be? Done. This is a question, though, that Kayvon asked about. If I had made you do all solutions here, take your calculator for me. Do 1/9 plus 2/3, math, enter, enter. What do you get? 7 over 9. Could you add another 2/3 and not be bigger than 2 yet? What would you get if you added another 2/3? And then if you had another 2/3, you're over, you're telling me? Okay, but we got 3 answers. So we would have had 3 more answers down here. Okay, so we would have had 6 answers. We don't have to do that for this question. I just want to tell you it is possible that you have to add it more than once. Okay, your assignment on this tonight is to do 2, 4, 6, and 7. Use substitutions on that worksheet, okay? Now, we're going to get to today's lesson, which is what we warmed up for earlier. Do you remember how easy it was?
Yeah.
We just looked at those and found them, okay? Yes, I'm on worksheet 6. Not today. My bad. 5 is really good. We're going to do some practice on Friday off of 5. But since I didn't get to finish 4 yesterday, I'm not going to do 5. Okay, here's 6. These are on your Trig reference sheet, which is peach. Not peach. Yes, it's peach. I already changed it. Okay, it's peach. I couldn't remember if I changed that or not. Last year it said pink, I think. But we already found them, right? Because we did our scavenger hunt first this morning. Okay, so we know where they are. Now, they can be used to find things like the sine of 15 exactly. Okay, I'm going to show you a couple of these. If you took trig, you did these. I am not a big fan of this because I don't think it's something super worthwhile, so I didn't put it on a quiz. Let me show you what I'm talking about, though. There's one on your sheet. It says the cosine of 340 or 375 is actually 330 plus 45. Why did I pick 330 and 45? I can break 375 down into 1 and 374. But I picked 330 and 45 because they're both on the unit circle, okay? Then I did that garbage off your sheet. Remember, cosine, cosine minus sine, sine? Then I put all the values in, got a common denominator, and simplified. Yeah, isn't that a beautiful answer? Square root of 6 plus square root of 2 over 4. I'd have just soon typed the darn thing in my calculator. How about you? To find the cosine of 375, okay? So we're going to do a little practice, but not very much. cosine of negative 15. Can anybody think of two numbers on your unit circle that would give you a negative 15? So you want to do 30 minus 45? You will get the same answer no matter what two numbers you pick, as long as the difference is 15. Okay, now tell me what the rule is for cosine A minus B. On your sheet, cosine A minus B says cosine A, cosine B. Is that what you said?
Yeah.
Plus sine A, sine B. Okay, what are we going to put in? We're going to put in a 30 and a 45. We already have the negative because we picked the one that had a minus here. So we don't have to use it as a negative. Nope. Our A is 30 and our B is 45. So we'll say cosine of 30 times the cosine of B is 45 plus the sine of 30 times the sine of 45. Okay, give me some numbers, guys. What is the cosine of 30? Cosine of 45, sine of 30, sine of 45. Okay. What does that become? This is square root of 6 over, nope, we're multiplying, so we do go ahead and multiply the denominators, right, guys? And over here, this is, okay. Can we add those? Because they have a common denominator. We get square root of 6 plus square root of 2 all over 4. That is the, and you can't simplify that. That's the exact value of cosine of negative 15. These aren't hard, but they're kind of useless in my mind, so I'm not putting this on a quiz. Let's do one more, though, so we can practice using these crazy formulas. Everybody okay? Going kind of fast, I know. Ooh, tangent. I don't think I want to do that one. Let's do one of these. These are both in radians. So I gave us some hints to make this go a little faster. 11 pi over 12 is really 165. So what are two numbers in degrees on your unit circle that add up to 165?
40.
Okay, 45 and 120. So then I changed them back to radians. Okay, you really could have done the whole problem in degrees because it just wants an exact value at the end. But if I made this cosine of pi over 4 plus 2 pi over 3, because I figured out that that's what those add up to, is 11/12. All right, how am I going to expand that? What is cosine A plus B on your sheet? Is cosine A cosine B minus sine A sine B, but what am I going to put in place of all those? Yep, pi over 4 and 2 pi over 3. Okay, that's a square root of 2 over 2. This one I'm not so sure about. Is it a 1/2 maybe? Minus, this is a square root of 2 over 2, and this is a positive square root of 3 over 2. Is that right? For everybody get where I'm getting those off the unit circle? They just correspond to what's above it. If I multiply these together, I get a negative square root of 2 over 4. If I multiply these to get it, I get a square root of 6 over 4, right? And then I can combine and I get a negative 2 minus the square root of 6 all over 4. Those numbers look a little familiar, right? Yes. You would get the same answer at the end. Okay? Your signs would probably be different along the way or something, but you get the same answer in the end. I'm going to just be done with these. Can you do one of those on the homework if you have to, maybe? I think there's one of them. All right. We're back to playing with our sheet. Which one? Do you have these? This next ones you have? We already are good at this, so I'm not going to go through too many examples. Sine, cosine, plus cosine, sine. Look for it. Sine, cosine, plus cosine, sine. Where is it? Sine A plus B. What are A and B, though? This is A, this is B. So I'd have the sine of 20 plus 10, which are in degrees, which is the sine of 30 degrees. Okay? If they wanted us to simplify, which I think they do, the sine of 30 is actually 1/2. Okay, number 6. How much time do we have? Oh, we're doing good, right? Because there's one more little piece to this. But let's practice one of these, because these are radians, and we all love fractions. Okay, tan plus tan over 1 minus tan tan. But our A and B are? Okay, why don't we use our handy dandy calculator? What's 1/9 plus 5/36? Math, enter, enter. What's 9/36? Yeah. Did you get a 1/4 on your calculator? Okay. Now, tangent is not our favorite animal. What is the tangent at pi over 4? Which is a 1/4 pi. Is everybody good with that? The ordered pair is this, right? So y over x is 1. Everybody good? All right. Uh-oh. Let's do 8. I'm not going to find either a pi or a 12 over a y on my unit circle anywhere. That's actually nice because it means I don't have to do that stuff. So, can you find one that says sine cosine minus sine cosine? What? Oh, I bet there isn't one on your sheet that says this is an A and this is a B, but the B is this and the A is this. Remember? Because it says here the A was pi over 12. I think they're just trying to trick us. So it has a sine and a cosine and a minus, right? Which one has a sine and a cosine and a minus? Okay, but it's supposed to go sine, cosine, minus cosine, sine. Is that okay? These are just two things multiplied together back here, right? They just tried to trick us by writing them in the wrong order. All right, so again, it was equal to sine of A minus B. And what are A and B? Guess what? We're done because we can't do anything with that. This is what they were looking for. They just tried to trick us. All right, last concept. Man, I thought I was doing so good. Okay, you have to do a verify on the quiz. Let me explain what a verify is. For a verify, you go to this. Please don't pack up. Sine A minus B and write that out. What should that say? It should say sine A. What is A though? Okay. Times, what's it say on your sheet? Cosine B, but B is X. Remember the minus was part of our A minus B here. And then on the sheet it says minus cosine A. What's A? Times sine B, which is X. I should have written that up here. Okay, go to your unit circle for me. What is the sine at pi? What is the cosine at pi? -1, right? Okay, so what happens when I do 0 times cosine? -1 times minus -1 becomes plus, and this is sine of x So did we just prove that the left side is equal to the right side?
Yeah.
Okay. Easiest proofs ever, right? Okay. Let's try this one. Can you find one that goes sine something plus something? Sine A plus B. What does your sheet say? Sine A cosine B plus cosine A sine B. So plug the numbers in. Sine of 270 cosine of theta plus cosine of 270 sine of theta. Okay, I just used this to plug these A and B values in. Okay, then I go to my unit circle. 270, the sine is, be careful, -1. At 270, the cosine is, so this all becomes 0, right? And this is negative cosine theta. It's a proof, guys, so make sure you show those little steps, okay? But easy peasy, yes? All right, look. This is your homework tonight, but I think it might be a little bit shorter. Can anybody read it to me off the homework check sheet? Anybody have it out? Yeah. Hey, just kidding. It's no shorter. Okay. But again, guys, remember that number 3, I think, is one of those where you get like square root of 6 plus square root of 2 over 4 or some crazy business like that. And then like in the middle, there's a bunch where you just simplify. You look at your sheet and you end up with tangent of 3x. And then there's a couple verify at the end. I'll answer homework questions tomorrow. Good job today, guys. Keeping up with all that.